Okay, so this is second tutorial. Here we will create our first input file and then we can see optimization or relax calculation. So the process is like we create input file and then we do optimization or relax calculation. After that we do SCF calculation, and after that we do NSCF calculation. Then after that we can do like band calculation, dose calculation, optical properties, mechanical properties, thermoelectric properties, uh, phonon dispersion calculation, like any other calculation. But first we have to create the structure and do optimization or relax calculation. So let's see how we can do uh, optimization. But first we will create input file for Quantum Espresso. Suppose we need input file for silicon. Okay, let's create input file for silicon. It will be easy for me to do the calculation because it has only, I guess, only two atoms. For that, we can go to one website. It is called Material Project. Let me open new tab. Yeah, this one, this website. You can simply search a materials project and you have to log in. So let me log in. And then here you can sort. So let's sort silicon Si, and then here you can see we have different crystal system. So we are choosing the most stable structure in which the energy above all is zero. So this one, the cubic one. So here we can click MP149, then click here, then click on CIF. You can save it anywhere. Let me save on downloads. After that, open Vista. This is the free software you can download. Then you can go to File, Open, and the location where you have downloaded, and double click it will open. So you can see this is for silicon. Let me save this as file, export data, any location. I will choose downloads, and then this option you choose bfgs file. Okay, so first we will create bfgs file and then I will use bfgs to convert it into input file for Quantum Espresso. So name you can give any name. So let's go to fractional coordinate. Yeah, fractional coordinate. Then simply you can close it. Now go to the location where you have save it. So here is si.bsp. Right click, open with Notepad++. So it has 8 atoms. Sorry, previously I have told 2 atoms. So it has 8 atoms. What you can do is simply you can copy this, Control Alt, Control C, then go to Linux, where there is your Quantum Espresso. So your system like supercomputer or Linux environment. So here let me create one new folder, Silicon Si. Then I will go to this folder and let me create a folder called Relax, CD Relax. Now here I will do nano postcard and I will paste this here. Control X, Y, enter. So this will save you. So Nano is simply an editor. With Nano, you can create file. And give me 10 seconds. With Nano, you can create file and you can write inside that file. Okay, so if you want to know about Nano, you can just search on YouTube, like Nano, how to use Nano in Ubuntu or in Linux. So I created the postcard here. Now we have to use bfgs. Bfgs, type bfgs and enter. If you want to install how to install bfgs, see my tutorial 1, tutorial first. There I have shown how to install bfgs. After that, you can simply type 416 and enter. 416 and enter. And it is asking for postcard 1 and enter. So it is saying error, the k points file not exist. So you have to create k point file first. So again, go to bfgs and go to 1. After 1, you can see in 102, you can create k point. So 102, enter. So we have three different types of k point here. So our structure is cubic. So for cubic, for supercell of cubic, like for cubic, we use option 1, and for two-dimensional materials like for graphene, like for molybdenum disulfide, we use gamma scheme. Okay, so this is not 2D, this is 3D, so we are using option 1. So you can choose any because this is just to create the input file. So for now, let me choose 0.02. So here you can see it generated the incar and k points. So go to k point and simply change it, like maybe, because here I want to just show you how to optimize. So if you use more like higher k point, then it will take more time to optimize or to relax. So for this video, I just want to, I do not want to take it long, so I'm just reducing the k point so that the calculation finished early. But be careful while choosing the k points. You have to choose higher k points for your better result. Now again, go to bfgs and then again 416, and then it is asking the structural file. We have postcard 1, enter. So you can see writing pwscf.in file. Okay, so here you can see we have this file. Now all these 3 files we can delete, we don't need. So for deleting, rm-r, then all these 3 files, it will be deleted. So now we have only 1 file. So I can remove this, sorry, I can move this. Move means like to rename mv, then this file name. So I am going to rename it as relax.in. So optimization and relax, same thing. Now again, I'm using Nano to open it. So here you can see the calculation. It is relax calculation. We have the title. We have the restart mode. So we have many information here. So one by one, you can go to like AI, like ChatGPT, DeepSeek, any of the AI, and you can just search it and try to get more knowledge on these tags. Okay, but here I'm not going to explain too much, but as we go on these tutorials, we may understand like what does it mean, but I'm not going to explain all the tags here. For now, I'm not going to explain. So here you can see these are the 8 coordinates of silicon, and these are the cell parameters. Like this is A, this is B, this is C, and these are the coordinates of the atom, and the K point we have here. So K point I will simply use 222 for fast calculation, or I can use 111 for the fast calculation because I need fast calculation for this tutorial. So we have one file ready. Now we need pseudo potential file. So in Quantum Espresso or any other software, you need pseudo potential file. So here you can see atomic species, and here is the pseudo potential file information. So this one and atomic mass. So we need two more things. So for atomic mass, you can just simply type atomic mass of silicon in Google, and then here you can see 28.085 in AMU. So unit in atomic mass unit. So 28.085. So double check this value. If it is wrong, then our whole calculation can be wrong. So double check our value. So this seems correct, 28.085. So here you can replace it. So in this terminal, you cannot use your mouse. So always use keyboard. And to paste, you can use mouse, but right click. Like for copy and paste, you can use mouse, but you cannot simply take mouse and click here so that the cursor moves. You cannot do that. So 28.085. Now to save this, Control X, then Y, then enter. Again, we need the pseudo potential file. We got the atomic mass. Now we need the pseudo potential file. So what you can do, search as PSCUDO pseudo potential file for Quantum Espresso. So here you can see Quantum Espresso website, and here is the pseudo potential. Just click it. I can see like different. It's look different than before. So here you can see ready to use PP tables are available. Click on available here. Yeah. So there is the table. So find silicon. So where is the silicon? Here 14. Silicon is 14. So SI here it is. Click here. So here you can find many different types of pseudo potential, but I usually use this one. I usually use this one. SIPBEN RRKJUS. So this pseudo potential I usually use. So right click and copy link address. Then go to here and then write WGET, then space, then paste that link and enter. So you can see it's downloaded here. So now we have pseudo potential file. Copy this and go to relax.e. Now go down. So we need to paste it here. So this input file will understand that, okay, this is the pseudo potential file. The name of the pseudo potential file is this, and it is available in that directory. So even you can create separate directory and you can give the link for it, like for here. Yeah, pseudo potential directory. So this is the home. Home means where there is relax.in. Pseudo potential file is also in that location. So if you write /, it will show like this. But you can create different directory for pseudo potential, and you can change the directory also. Okay. So if you do that, this is also fine. Like for out directory also, you can always change the location. But it's fine. You can use this one. And title, for all other coming calculation, you have to keep the same title. Okay, do not change the title. Like you can change it now, but in next calculation you have to use the same title. Like for now, if I change the title as suppose cat, so in next calculation also you have to use cat. Okay, if you alter the title, the calculation will have the error. So here is the first convergence. Here is the total convergence. So you can see in some research paper that, okay, the energy convergence is like 10 to the power minus 8, 10 to the power minus 4. So these are these values. Okay. So if you read the research paper, you can find this information there. And also for your work, like when you do your calculation, when you write, after that, when you write your thesis or for your research paper, you will know, you need to know this information, and you must write it on the calculation part. So let's save this for now. Now we have pseudo potential and we have input file for optimization. Now I need a script to run the calculation, like I'm using supercomputer. So for this, I have some script. I'm going to copy that script here. So let me copy this here. Let me go back to this location. So I have this script. So this script varies. It will be different in your case. So I have this. I'm going to use one node and 64 tasks per node, and development mode I can run for like 30 minutes maybe. Here is the time. So this is different in your case. Let me run for 30 minutes, and here you can see relax.in, the same name, and then this is a relax.out. Okay, so I'm running pw.x. This is for Quantum Espresso. pw.x, relax.in, and relax.out. So after complete, it will give us relax.out, and in the end of the relax.out, it will show job done. Okay, so we have to check that. Okay, let me run this. No, sorry. So it's running. So it may take some time to run and complete. I'm going to pause the video and I will be back after it completes. Okay, the calculation is completed. So you can see it has generated some files like this, 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 and this in my case. In your case, it can be a little different. Relax.out. So this is the file that we need. So we can check it through cat also, like cat relax.out. So you can see this was terminated on this and job done. So it is completed. So this is how we do relax calculation. So after it completes, so if you go above, you can see these are the final coordinates. Okay. In this case, like here, we have done geometry optimization in which only the coordinates are changed. Okay. But we haven't changed volume. Only the atom's coordinates are optimized. The volume we haven't optimized, because if we see our relax.in file, here you can see the calculation is only relax. So if you use VC relax, then in that case, the volume is also optimized. That means if you use relax, these coordinates are optimized. If you use VC relax, it will relax also the cell parameters. Okay, this one. So if you want to optimize both cell parameters and atomic position, you have to use VC relax. VC hyphen relax. You can search here. VC relax. You can see the calculation is like this. VC relax. Okay. Oh, it has two coordinates. So this is different calculation. This is different structure. Silicon, it has only two coordinates. That's fine. In our case, we have 8 coordinates. And after this, we will have to perform SCF calculation. Okay. So for that, what we can do, we can create new folder mkdir SCF like this. So it created SCF folder. So inside SCF folder, we need to bring some files that I will show you in next tutorial. Thank you.